Hi and Assalamualaikum. Today we will be presenting finding lost cat using TSP method for our group project CSC 645. This is our group members, which is AMEER, LUKMAN, NORHAKIM, HASIF, DANIAL, RAIHAN, AZHARI, Muhammad Haziq and Muhammad SHAFIZAL. Introduction to the problem. Pets are more than animals. They are family, bringing love, comfort and joy. Losing a pet is emotionally distressed and creates a stressful situation. This project focuses on locating a missing cat named Whiskers in a quiet neighborhood. We use graph theory to model the neighborhood with houses, trees, alleys, backyards and roads as nodes and edges. Scores are assigned to each path based on cat behavior. For example, preferences for quiet, shady areas. We apply the traveling salesman problem to find and optimize our search route. TSP ensure minimum travel time while maximizing the chance of finding Whiskers. The system helps volunteers search effectively, ensuring no place is skipped or repeated unnecessarily. Demonstrate how computer science can solve real-world and emotional problems.
Moving to problem based on the existing real-life scenario, I will give explanation of the problem. Lost cat often hide in quite dark and hidden areas, making it hard to find. Traditional search methods like flyers and calling out are mostly based on luck. Most people don't consider cat behavior when searching it, so there needs for a smarter system that can use cat habits and location data to guide the search effectively.
And I'm going to present about problem based on existing real life scenario. This is real life example. A cat named Milo went missing from a backyard. The family searched days using poster, shelter and wide area searches. Milo was found 5 days later, just 2 houses away, hiding under a neighbor deck. Fear kept him from responding even when called. If the family had used method based on common cat behavior, they could have found him much earlier. This shows cats often stay nearby but hide quietly and unnoticed.
Next, to solve the problem, we use a smart computer approach called the traveling salesman problem. First, we build a graph that represents the neighborhood. Each location, like houses, alleys, or trees, becomes a point and we connect them based on how likely a cat would pass through using weights. Then we apply the TSP algorithm to find the shortest path that visits every important location once, starting from house A. This helps reduce wasted time and ensures no spot is missed. Next, we create a visual simulation. As the search progresses, it shows visited places in peach, the current location in orange, and the start and end clearly marked so it's easy to follow. Finally, we ran the full program, combining all steps to create an efficient and realistic search plan. This method saves time and increases the chance of finding whiskers quickly. In conclusion, our project shows how computer science can help solve real-life problems. We use graph theory and the traveling salesman problem to model a neighborhood and predict where a missing cat might be. By assigning weights based on the typical cat behavior, we created an optimized search route that saves time and avoids unnecessary repetition. In our case, we can classify it as a redundant paths. Our visual simulation makes it easy for volunteers to follow the path. This project proves that algorithms are not just technical, they can also bring comfort and connection in emotional situations.
So now I would like to present or show the real life simulation on finding the missing cat program. So as you guys can see, this is the whole complete program on finding the missing cat using TSP algorithm. So we can click the run button and the output should be like this. So we begin the search at house A, the starting point. So from there, we move to the backyard, a calm and shaded area that cats tend to favor. So since Whiskers is not there, we continue to the tree, another likely hiding place because it is quiet and elevated, but still no sign at all. So next we go to house B. While it might seem far from the tree, the algorithm has calculated that going this way now minimize total travel. So then we head to the bushes and this time we spot whiskers and a red note appears marking the successful end of the search. So now you might wonder, why didn't we visit closer spots like the garage or fence gap first? So that's because TSP doesn't make decision based on the next best move. It evaluates the entire route for efficiency. The algorithm has weighted each path based on how likely a cat will hide there. For example, quiet, shaded or hidden. And it picked the optimal overall journey from start to finish. And this simulation shows how combining cat behavior with smart algorithm helps volunteers search efficiently and increase the chance of finding a missing cat quickly. That's all from me. Thank you.